Okay, welcome America, welcome Taylor Swift to our recording in Studio 212 live today. We are going to be graphing a couple tangent graphs today, and I want to make sure I do problems 1 and then maybe I might move to number 5 after I do problem 1 because I've already recorded problems 2 and 3 that are also in this same playlist if you would like to look at those problems. And I will attach this worksheet and the key so you can look at those problems if you'd like. All right, let's get started. So, last class we graphed sine and cosine functions. You guys look great today, by the way. Okay, it's dress up day, it's time travel day. Okay, so the parent functions for sine and cosine have a period, okay, one full period of 2 pi, right? And then the graph starts over. The tangent, as we have learned in our the video that we watched before class, the tangent has a period of pi. So we have to be careful with that when we are setting these problems up to graph. So we'll go ahead and start. The amplitude is exactly the same as sine and cosine. So what is the amplitude for problem number 1? 1. Okay. The period for the parent function is pi. So the period for any tangent function is pi over b. B is the leading coefficient for x. In this case, it's a 1. So what's the period of this function going to be? Pi. Which makes the unit, we're chopping that period up into 4 nice even pieces. So we're going to do pi, cut it in fourths, pi over 4. We're counting by pi over 4. So I'm going to come over to my graph, and I am going to just write a pi over 4 just to let myself know that that's what I'm counting by. Now, this problem does have a phase shift. I was kind of hoping to start with the problem without a phase shift, but that's okay. We'll go ahead and start with the phase shift. So we're going to go ahead and set what's inside this parentheses equal to 0. You can probably do that in your head. You set that equal to 0. What's the phase shift going to be? X plus 3 pi over 4 equals 0. Subtract 3 pi over 4 from both sides. You get x equals . Okay, and the vertical shift is -2. I think everybody after last class is comfortable with the vertical shift. All right, so we're going to move our new 0, 0, and we're counting by fourths. We're counting by pi over 4. We're going to go to the left because we're going negative 3 pi over 4s. So 1 pi over 4, 2 pi over 4, 3 pi over 4. And then, so I'll put a little dot there, and I'll make it a little bit bigger because we can't see those dots as I have learned when I rewatched these videos at night. So we're shifting to the left 3 units, and now we also have to shift down 2, and I'm going to use the highlighter for that. Because really any of the stuff that we're putting on our graph here, after we do the graph, we want to erase it. So that's just to kind of give us an idea. So really, here's our new x-axis, and here's our new y-axis. So it's going left 3, down 2. So our new 0, 0 is at right here. Now, we are going to go ahead and graph the parent function of tangent from that new starting point. Tangent of 0 is 0. Tangent of pi over 4 from the unit circle. Do you remember this from the video that we watched last night? So we've got 0, 0, 1, 1, -1, -1. And then we have, at pi over 2, we have an undefined because the tangent of pi over 2 is undefined. So from the 0, 0, I'm going to go over 1, up 1 because our amplitude is 1, so we don't have to worry about a stretch. Left 1, down 1. And then I'm also going to draw with the highlighter. let's see, my asymptotes. So I'm going to count over 2, left 2. So now that's one full period. 1, 2, 3, 4, 4 units. And from there, all you need are those 3 points. We're approaching asymptotes on either side. And that's it. Now we're going to repeat it. Now you can go ahead and set these equal, as I showed you in the video, to pi over 2 and solve for the asymptotes and put them in. But I think it's easier to find your new 0, 0, count right 2, left 2, put your asymptotes, and then repeat them. And just count by 4. 1, 2, 3, 4. There's your next asymptote. 1, 2, 3, 4. There's your next asymptote. 2, 3, 4. Next asymptote. When I make mistakes doing these, it is usually with the vertical shift. Forget to shift the function down. But today we have got it. And you do want to draw the entire graph across your entire grid. Okay. The domain is the hardest part. Yes. Kelsey.
For the phase shift, when you go -3 to the left, are you starting from 0, 0 or from pi over 4?
Yes, you're starting from 0, 0.
Okay.
So your original parent function from the video last night, the tangent of 0 is 0. The first unit is pi over 4. Tangent of pi over 4 is 1. So those points are already plotted, 0, 0, 1, 1, for example. Okay, we're taking those points and we're shifting them left 3 pi over 4, because we're counting in fourths. I tried to make the unit easy for the first one because, you know, we don't want to do anything too crazy for the first one. Jasmine.
Where do you, how do you know where the next points are on the graph for like the next asymptote?
After you get the first one,
Yeah.
you're just redrawing this. The period's going to repeat itself. So you're just repeating that.
Okay.
So once you get the first period and you put those points in and you draw your graph, then you're just going to copy and paste it.
Okay.
And so I first draw the asymptotes, right? Count 1, 2, 3, 4. Put your next asymptote 1, 2, 3, 4, because there's an asymptote after every period, which is our issue with our domain. Are we good? Okay. So the domain for sine and cosine, we've got this repeating graph looks like this, right? So we can plug in any x value, we're going to find a y value. If we shift it horizontal, if we have a phase shift, or if we have a vertical shift, we're still going to have a point on our graph. For tangent, we've got these undefined values, okay? Where the tangent of pi over 2 is undefined. So we have to pull those values out of our domain. So we usually start with, we just say x cannot be equal to, and we usually just start with the first one that's to the right, but you really can start with any, okay? But we usually pick the first one that's to the right of the y-axis. We name it, and then we figure out what the period is, and we say we can't have that value plus the period plus another period plus another period for an infinite number of periods. So let's first figure out what that is. So we're counting by pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4. Our first asymptote to the right of the y-axis is 3 pi over 4. So x cannot be equal to 3 pi over 4. I'm going to have to explain this about 32 times, not just today, multiple classes, and we'll get it, okay? Now, we have to include, what's the period here? What did we decide the period was? Okay, so the period is pi. So the next asymptote is going to be, if I add pi, right? So if I do plus pi, I'm going to get my next asymptote. Well, I need to tell everybody that's going to happen after every single period. And when we do that is we just put a k next to it. K is a whole number, 1, 2, 3. So every time we have 3 pi over 4, I need to add pi how many times? Plus 1 time, plus 2 pi's, plus 3 pi's, plus 4 pi's. 3 pi over 4 plus if I subtract pi, I get another asymptote. If I subtract another pi, I get another asymptote. And the way we do that is we just say k pi's, okay? So plus pi k. And that will include an infinite number of asymptotes every pi values. That's the hardest part. And there's also one extra step to that in another function. I'm probably gonna have to do a second recording. This video is kind of long. Wyatt.
Instead of using the 3 pi over 4 for your asymptote in the domain, can you use negative pi over 4?
You can. It's just most of the time, the way we teach it is we just pick the first one that's to the right. But you could essentially pick any asymptote and add pi to it k times, and that would include all the asymptotes. All right, so the range is, you can see, even if I just select this first graph that we drew here, this first interval, every single y value is going to be included because we've got the graph continues down forever, the graph continues up forever. So the range for the tangent here is negative infinity to positive infinity. We're going to have to do a separate video on just domain and range. That might be a good idea. We'll do that another class. All right, thanks for coming out.